Hello everyone, I am Mr. Pang Hokkien from Curtin University, Malaysia. So welcome to the workshop 3, which is about prototyping and developments. In these sections, we are going to explore how we can move from ideas to something practical, testable, and useful. Now, many projects, do not fail because of original idea is bad. They fail because of the team spent too much time doing discussions or trying to build too many things at one time or wait until the final moments before starting the actual development, which we call it as last minute. Okay, so sometimes students have a very creative ideas. They can explain well the ideas, they can describe many features and many future possibilities. But when we ask them to show how the product is works, we can see that they can only show a very little evidence that the idea can actually works. So that is the gaps we want to close today. This workshop is not about creating the perfect product immediately. It is about learning how to build the right thing first. So we're going to start from develop a prototypes that allow us to test our assumptions, understanding the problems better first, and improve the project step by step. The goal is simple. You do not build everything at once. Build something that is small enough to test, but meaningful enough to teach you what to do next. So today we are going to use a simple frameworks, which I call it as build frameworks. So the build is very easy to remember because prototyping is ultimately about building. Then after that, testing, learning, and improving. So before we look at the frameworks, let us first understand why prototypes matter. A prototype is not just to build to impress people. It is not something that is attractive that we're going to show it during competitions, exhibitions, or final presentations. A prototype should help us to remove uncertainty. At the beginning of the projects, we usually have a lot of questions. Can the idea works? Will the user understands it? Will the technology perform as expected? Can the teams complete it within the expected time? Will the cost become too high? Can the projects grow beyond one prototype? There are too many uncertainties. Okay. So that's why we need to create a good prototypes to give us that evidence. It should able to help us test our assumptions before we invest, too much time, money, and efforts. For examples, imagine that a teams want to build an intelligence recycling systems. The final visions, may include smart bins, artificial intelligence, or automatic leads, mobile applications, or reward systems, and even a cloud dashboard. That sounds impressive, correct? But before building all these features, the team must answer a more basic questions. Can the systems correctly identify the waste? If the answer is basically no, then the beautiful enclosures, mobile applications, the reward systems do not matter yet. The prototype should be first test the uncertain parts. So that is why it called prototypes to help us to learn faster, reduce the risk, and improve the solutions before scaling it. The earlier we discover a weakness, the easier and the cheaper it is to correct it. So if you put it later to discover, more times required or more resources you are needed, before you able to complete it. So it become a lot of waste. So always remember, prototyping is not only models of your idea. It is just a learning tools. So to guide the development process, we will use the build frameworks. So each letter represents one important step. First, B means begin with why. So before building prototypes, we must understand why the solution should exist. U means use MVP mindsets. Okay, MVP stands for minimum viable products. We normally brainstorming widely, okay, but we have to select a small numbers of priorities and begins with building the most important function first. I means illustrate with demo. So we do not only explain the ideas, we also need to show the problems, the prototypes in actions, and the difference it creates. Then next, we'll go for L, means look at feasibilities and scalabilities. We must examine whether the projects, okay, can realistically be built and whether it can grow beyond the first prototypes. Finally, D means do something now. A workshop is useless if we just live with more ideas but no actions. Every team must decide, okay, what it will build, who is responsible, when it will be complete, and how success will be measured. So to conclude on this, okay, a complete flow is first begin with why, then use MVP mindsets. After that, illustrate with demo. Next, look at feasibility and scalabilities. Finally, do something now. The build frameworks, okay, help us move from imaginations to executions. It also prevents a common mistakes, trying to develop the full products before proving that the core ideas is works. The first part of the framework is B. Begin with why. Before discussing the technology, we must understand the problems. Who is the user? What is the difficulties is the user facing? Why does the problems matter? What happens if we do nothing? These questions may sound simple, but many project teams do not answer them clearly. Sometimes students start with the technologies. They may say, we want to build a mobile apps. We want to use artificial intelligence. We want to use Internet of Things. We want to use a robot. But technology is not the why. Technology is only one possible tool. Okay, the real why comes from the user and the problems. For example, saying we want to build AI applications. That does not explain why the application should exist. A stronger explanation would be we want to help elderly users detect possible health changes earlier because they may not notice the symptom themselves. Okay, so now there is a user, we got a problem, and we have a reasons. When the why is clear, then the teams can make better decisions. It becomes easier to decide which features are important and which features are unnecessary. Okay, it can also becomes easier to communicate the projects to the judge, investors, lecturers, and users. Without, without a clear problems, the projects may become a collections of technologies without a meaningful purpose. Okay, that is why I often say prototypes without a real problem is just a technical toys. Okay, it may be interesting, it may be complicated, okay, it may even look impressive. But if it does not solve a meaningful problems, its value will be limited. Okay, a simple way to clarify the why is using these statements. Okay, we are helping this user solve these problems because this negative impact is happening. Let us look at the structures. First, identify the users. Do not say everyone. When a team say that the product is for everyone, it means that the target user is not yet clear. So you need to be specific. Is it the user a student, a lecturer, a small business owner, a parents, a person with a disability, or even event organizers. Second, identify the problems. Okay, what is the difficult, slow, expensive, confusing, dangerous, or efficiency? Third, explain the negative impact. Why is this problem worth solving? Okay, for examples, we are helping students register for activities more easily because manual coordinations causes confusions, delays, or even missing records. Okay, this sentence gives the teams a clear directions. The user is a student. The problems is the registration process. The negative impact is confusions, delay, and missing records. Once the team understand this, okay, it becomes easier to determine what is the first prototype should do. The prototypes does not need, okay, to solve every problems related to university activities. Again, it should first improve the registration process. This level of clarity is important because problems create bigger solutions. So the problems is specifics. The prototypes can also become specifics. Before you build, make sure that your team can explain the projects in one clear sentence. If the explanation is confusing, that means your project are probably still too broad. The second part of build is use MVP mindsets. MVP means minimum viable products. But I do not want you to think that MVP is simply a cheap or incomplete product. Okay? The MVP is actually the smallest useful versions that allow the team to test the most important assumptions. When I guide my students, I always encourage them to brainstorm freely. Just write down every idea that is discussed. I ask them do not reject any ideas too early. Okay, so during brainstorming, the main purpose is just generate possibilities. Some persons, okay, may suggest, okay, a mobile applications. Another may suggest automatic notification systems. Someone else may suggest artificial intelligence, facial recognition, a sensor, a dashboard, a reward systems, or even a new feature. Just write them down. Okay, ideas that cannot be used in the first prototypes may still become useful later. Okay, however, brainstorming must eventually lead to a decisions. This is where many teams become stuck. I always see students discussions, okay, ideas again and again. They suggest one idea, then reject it again. They suggest another idea, then say it's too difficult. They continue looking for a perfect idea because they cannot decide. In the end, they delay the projects. Okay, so eventually the deadline become very close. Then they select an idea quickly and attempt to build everything at the last minute. Okay, the problem is not the students lack ideas. Okay, the problem is that they do not prioritize and begins. After brainstorming, okay, the team should review the list and select the top, okay, 1 to 3 priorities. Ask which idea solve the most important problems. Which idea provide the clearest value? Then which idea can be tested, okay, with time, skill, and resources available? Then choose the first priority and build it. Do not attempt to build every functions at the same time. Okay, build the most important functions. Test whether it works. Observe the results. Improve the prototypes. After the first prototypes work well, returns to the brainstorming list. Okay, the second, the third ideas can become the next improvements. The remaining ideas are not rejected. They're simply placed in the correct sequence. This is very important. Okay, every ideas can be valuable, but not every ideas must be built at the same time. The MVP mindset is not about reducing creativities. Okay, it is about organizing your creativities. It allows the teams to think broadly, prioritize clearly, and build one important things first. The working simple prototypes give the teams confidence and evidence. Okay? Unfinished complicated prototypes give the team stress and excuses. Now let us look at the practical example using IEEE CMSP apps. Okay? So IEEE Curtin Malaysia Student Branch have created apps. But before these apps are built, okay, we have to sit down and brainstorm the ideas that what we want to do. So this is some of the lists that we have brainstormed, like event registrations, member registrations, attendance trackings, schedule of upcoming activities, competition management, newsletters, IEEE media, feedback forms, education games, and admin analytics. Okay, but from there, we only choose three priorities. Okay, so first is our event registration, second newsletters, and third is schedule of upcoming activities. So we choose our event registrations as number one as a priority because at that time, okay, we have events called STEM playgrounds. So during the STEM playgrounds, okay, we got before this, okay, we have already have a STEM playgrounds. Then we are manual registration, do manual registrations for the participants and publics. That is very tedious. It takes a lot of times and it need a lot of helpers. So in order to solve these problems, okay, so we create these apps. So inside the MVPs, okay, so we have to mention that we need event informations, we need participants registration forms, and we need basic participant list for the organizer, and finally public registration form. Okay, we have to do this four first. We prioritize on doing this four. Then by doing this, okay, we go to prototype. Okay, we try to test whether it's success or fail. Once it's completed, once it's success, okay, then we do uh, more buildings, more features, okay, into these apps. Okay, at this point, I would like you to apply the MVP mindsets to your own projects. So please pause the video for the moment. So first, please write down all the ideas your team has discussed, but do not reject or remove the ideas. Okay, second, choose the top 1 to 3 priorities. Then third, okay, select the one functions that should be built first. And finally, complete these sentences. Our first prototype will test whether. So your answer should be clear. Okay. For example, our first prototype will test whether user can register without manual assisting. Or it can be our first prototype will test whether the sensor can detect the required objects. Or it can be the first prototypes, okay, will test whether the systems can classify the data accurately. So do not continue until your teams has choose the first priorities. Okay, discuss without a decisions is not a progress. So please pause the video now. So welcome back. You should now have a one clear first priority. Okay, that priority become the focus of your first prototypes. The third part of build is I. Okay, illustrate with demo. Okay, a demo is not only a presentations, okay, of your technologies. A demo should prove that your prototypes create value. Many teams make mistakes of explaining too much. Okay, they're explaining the programming language, they're explaining every sensors, they explain the database, circuits, tools, and components. These details may be important, especially during the technical evaluations. Okay, but they are not the main purpose of the demo. So the audience or the judge, okay, wants to know what problem does it solve. Okay, what happens when the user use the prototypes? What results appear? And what difference does it create? A good demo show four things. Okay, first it show the problems. Second, the actions performed using the prototypes. Third, the results. Fourth, the difference compared with the current situations. So for examples, please do not just only say that your system use a camera and artificial intelligence model. You should show, okay, objects in front of the camera, should show the system recognizes it, show the outputs. Then explain why this output is useful. The demonstration should connect, okay, the technology to the value. Remember, okay, this simpler form. Show the before, show the products, and show after. Okay. So when your demo is clear, the audience do not need to imagine how the ideas works. They can see the evidence itself. To make the demo easier to structures, we can use another simple frameworks called PAT. PAT. Okay. P means problems, A means actions, then D means differences. Okay. First, show the problems. What is happening before the solutions is introduced. So for example, the IEEE apps, manual event registrations may require organizer to collect the names through message, paper forms, or different online platform. So this become confusing and time consuming. Second, is the actions. What does the user do with the prototypes? So the users open the application, select the events, and complete the registration forms. Then third, show the differences. What become better? So the registrations may be completed within 1 minute. Okay, or the participant receive confirmations. The organizer receive a clear participants list. Okay, so there is a difference, and it must be visible and understandable. A weak demo, only show the technology, but the strong demo show improvements. If possible, use measurable evidence. Instead of saying, the process is faster, okay, say that, the registration times is reduced from 5 minutes to 1 minute. So another one, instead of saying systems is accurate, show the test results. Then you can be, instead of saying the interface is easy to use, show the user complete the task without assistance. So evidence make the demo strongest. So once again, PAT structure keeps the presentation focused, your problems, actions, and the differences. So just to update what is going on with our IEEE apps. So for the initial, the problem that we'll solve, we uh, done already, but after that, because after MCO, there's no longer a big events going on. So we change our apps to more towards a community outreach. Okay. So our apps is now is open, to everyone to see, our upcoming activities, our newsletters, our medias, and even now we implement some education games in it. Okay. So right now, this is what we have improved, and hopefully based on our brainstorms, we'll continue to improve our apps time by time. Okay. So this is our IEEE apps for now. Okay. The fourth part of the build is L. Okay. Look for the feasibilities and the scalabilities. Let's just begin with feasibilities. Technical feasibilities means asking whether the solution can be realistically be built. A good idea is not automatically feasible projects. The team must examine several areas. First, the skills. Does the teams have the knowledge required? Can the members programs the applications? Can the members design the circuits? Can they develop the artificial intelligence models? Okay, if the skills are missing, can they learn them within available times? Then second is the tools and components. Okay, so are the required software, sensors, machines, and material available? Okay, all this you need to check before you decide the projects. Then third is the cost. Okay, can the prototypes be built within the budgets? Okay, what will happen if the cost, okay, if more units are produced? Okay, all that you need to consider. Then fourth is the time. Can the important functions be complete? Okay, before the deadline? Okay, you have to schedule your, or you have to plan properly. Okay. Then the fifth is technical risk. Okay, what is the parts that may cause the projects to fail entirely? Okay, for example, uh, AI systems. Okay, the main risk may be the accuracy of the model itself. Okay, for electronic systems, it may be the sensor reliabilities. For mobile applications, it may be the database or the user authentications. Okay, so do not spend weeks creating a beautiful enclosures or while when the sensor is still unreliable. Okay, or you do not spend too much time designing the interface. Okay, if the main algorithms has not been proven. Okay, do not create promotional materials before confirming that the prototype is working. So always test the risky parts before polishing the easier parts. Okay. So feasibility is not about being negative. Okay. It's just about being honest to yourself. Okay. A strong engineer does not only ask, can I imagine this? Okay. But you will ask, okay, can I build and test this responsibly with the resources available? That is for feasibilities. After feasibilities, we examine scalabilities. Okay, one successful prototype is important, but it does not automatically means that the idea is ready to grow. Okay, we can use a simple test: 1,000. Okay, so how are we going to use this? Okay, first, can the team build one prototype that works? Okay, this is just to prove the basic concepts. Then seconds, okay, can the solutions work with 10 users or 10 units? Okay, so you need to think, okay, can another persons operate it without the developer standing beside them? Or can the teams reproduce the same results? Then third, okay, what happens when there are 1,000 users or units? Okay, how can the system handle the data, or how the server support the traffics, and how the team management maintains, okay, trainings, support, and costs. Okay. So for example, the IEEE apps, okay, the first questions can be like, can one participant register successful? Okay. Yes, it can. Then we go to the second questions is, can one events teams manage registrations for actual activities? So we do the testings. Yeah, we can. Then the third questions comes again. Can the system manage a large number of participants? The attendance records, okay, and the uh, organizer list, okay. So all this is part of the scalabilities. So scalabilities is not only about software or technologies, okay. It is also need to be include people and the process, okay. Who will support the users? Who will update the informations? Who will correct errors? Who will maintain the systems after the students teams graduates? Okay, just like our IEEE apps, our students teams already graduate, so we need new teams to come in and they need to continue on improvements of these apps. So for a project may works during the competitions, but it will disappear. Okay, if the idea is good, it's very good, but nobody is going to take over it after the competitions. Okay, that will become a scalability problem. So a powerful questions to ask is, what will brag when the projects become successful. Okay, if 100 people begin using the products tomorrow, what problems will appear first? Okay, the answer show the teams what should to improve before scaling. Okay, so this is the scalabilities that you need to take note on. Now, please pause the video again. Okay, so this time examines the feasibilities and scalabilities of your projects. Answer these four questions. What is the biggest technical risk? Okay, what must be tested first? What will break if many users begins to use the solutions, and what must be improved before the projects can scale? Okay, be honest. Okay, do not hide weaknesses. A strong team is not a team without problems. A strong team identify problems early and respond to them. Okay, so please pause the video now and discuss these questions with your teams. So welcome back. Okay, you show now that a clearer understandings of the technical risks and the possible scalability issues. Okay, these findings should influence what you will build next. Okay, now the final parts of build is the D. Do something now. This is where the frameworks become actions. Okay, you may have a clear problems. You may have understands the MVP mindsets. You may have a good demo plans. You may understand the technical risk. But if nobody begins the works, nothing's change. Okay, every team must make four decisions. Okay, what will we build first? Okay, who is responsible? When is the deadlines? And what result proof success? Okay, so using this sentence, within these periods, we will build these MVPs to test, okay, these assumptions, success in these measurement results. Okay, so for examples, within 3 days, okay, we will build a simple event registrations prototypes to test whether participants can register without assistance. Success means that at least 8 out of 10 users complete the process successfully. Okay, this is much stronger than saying, okay, we will start developing the application soon. The word soon is not a deadline, okay? Development, the apps is not clear task. Okay, make it better is not success measurements. Okay, so actions must be specific, owner must be clear, deadline must be visible, result must be measurable. Okay, this is where many projects need disciplines. Okay, a teams must stop discussing everything and start testing something. So this is the last. Okay, do something now. So let us conclude by returning the build frameworks. Okay, begin with why, clarify the users, the problems, the purpose. You use MVP mindsets, brainstorm freely, record the ideas, select the priorities, and build the most important function first. I illustrate with demos. I show the problem, show the prototype in actions, and show the differences it creates. L, look for feasibilities and scalabilities. Okay, check whether the projects can be realistically being built and whether it can grow. D, okay, do something now. Decide the next prototypes, okay, the responsible persons, the deadline, and the success measurements. Prototyping is not about building everything immediately. Okay, it is about building the right things first. So do not leave these workshops with only a bigger ideas. Okay, leave it with a smaller prototypes, live with a clearer text, live with a stronger action plans, think broadly, prioritize clearly, build carefully, test honestly, improve continuously. Okay, and when the first prototype works, return to your original ideas and continue developing the projects step by step. So build smaller, learn faster, scale wisely. Okay, that is how we build to learn. Okay, so thank you, and I wish you all the best with your projects. Okay, see you guys. Bye.